Okay, so now we did the domain. We just did that in the previous video. Now, what we're going to consider is the range. Now, what's nice about sine and cosine is their ranges, both of them have the same range, in fact. That is, both of them have range equal to this interval, negative 1 to 1. That's what the range is. Okay, now you might be asking, well, why is that true? Well, it's really not hard to show, actually. Let's show it. So, for instance, we're going to show it for cosine. So, I'm going to let t be any number, okay, in that interval, negative 1 to 1, okay? Okay, then what? Well, if we went back to the unit circle, as we have many times before, right, like so. Okay, so there's our x-axis, there's the y-axis, right? Now, since t is in this interval, that tells you t is between negative 1 and 1. Here, this point on the edge here, this has coordinates 1, 0. This has coordinates negative 1, 0. So t is going to be some number on the x-axis between these 2 points. Between these 2 points. Okay? So, for instance, let's say t was, I don't know, let's say t was over here. Actually, no, let's actually make it easier. Let's say it's over here, okay? Just to make it easier. Okay, so if t is over here, then if we were to go up to this point, okay, this point here is going to have coordinates t, comma, y for some number y. All right, big deal. How does that help us? Well, what if I draw this angle in standard position? Now, I don't know what this angle theta is, but really it doesn't matter because P for this angle theta is going to be this point. In other words, so our P will be, in this case, t comma y, and so that tells us cosine of theta is going to equal to that number t. So cosine of something is equal to t. Hence, it follows t is in the range of cosine. A similar argument does hold for sine. The only difference, though, is that your t is going to be on the y-axis. Okay? I'm not going to show that here for time consideration. Okay? All right, so let me move on. So here we're looking at some trig identities. And I did say this before, but a lot of the identities from right triangle trigonometry carry over here. We have actually seen these identities earlier in the course. So I guess these identities really are nothing new. They just follow directly from the definition. These, however, might be new. It actually turns out once you prove this identity here, you get the other two here. You get those immediately. Really just from the, the reciprocal identities right above it. Before I show that, here's some fancy notation. Basically what we have here is this. So instead of writing this here, people like to write this instead for convenience. So these identities are written this way. So that's what we get here. Okay, so how do we get that? Well, let's see. If we take, again, going back to the unit circle as before, right? So again, let's say theta was so I don't know what angle theta is. So let's say theta was in this quadrant. Quadrant 4. So it's going to go like this. Okay, again, it doesn't have to be in this quadrant. But anyway, this point P over here, right? That's going to have coordinates x, comma, y. And really by definition, cosine of theta is equal to x, sine of theta is equal to y. Now, also, an equation for this circle is x squared plus y squared is equal to 1, because again, it's the unit circle, so that tells us its radius is 1, but all you have to do now is just take these two and plug them in. You plug them in, and you get this identity. So we have we have this identity here, sine squared plus cosine squared of theta equals 1. Now, how do you get the other ones? Well, if you take sine squared of theta plus cosine squared of theta, okay? Well, if I were to divide everything by cosine squared, like so, so I'm dividing everything by cosine squared of theta. Okay, you might be thinking, well, how does that help us? Well, the first term here, sine squared over cosine squared, that's the same thing as tangent squared of theta. Cosine squared over itself is just 1. 1 over cosine is secant squared of theta. In fact, that's actually one of the above identities. Okay, you can see secant is 1 over cosine. And sine over cosine is tangent. Okay, it's supposed to be a comma here, but I guess that's okay. There we go. But that's how you get that. And a similar calculation, you just divide instead of by cosine squared by sine squared. That's how you get this identity.